All right, you know what to do. We are going to be covering 4.01 Understanding Translations and Reflections. Make sure you have your math notebook and something to write with. Don't really need a calculator for today's lesson. Just make sure you are ready to take notes and work those examples. All right, we'll go ahead and get started. So our essential question is, what is a translation and reflection on a coordinate plane? Today, I will use math vocabulary to describe transformations and explain the effect of those transformations over the x or y axis using algebraic representations so that I can determine the effect of transformation given the data. I'll know I got it if I can represent transformations algebraically on a coordinate plane. All right, so let's go ahead and see what that's all about. First, we're going to look at reviewing congruent polygons. Definition here says congruent means that two shapes exactly match. These shapes have the same size and shapes, even though their orientations may differ. These shapes are of same size and shape, so these shapes are congruent. A symbol commonly used for congruency is an equal symbol with a tilde above it. Right here, that means congruent. So in this example here, it says triangle ABC is congruent to triangle DEF. Now notice how they have it marked. This angle here is congruent to this angle. And then C is congruent to F, and then E is congruent to B. Now if this DEF was turned, you'd have to be careful with matching those up. But when it's written this way, it will always be matched up this way. This angle is congruent to the first angle here. B is congruent to E, and C is F. So angles are fairly easy when you have triangles. The sides here, you can see this side has one little mark, so does this side. So those two are corresponding sides and are congruent. These two match up. And then over here, AC and DF. Again, another way, since this is written out, if this was turned and it confused you, you could just match up the letters. This first two, AB, goes with DE. BC goes with EF. And then you have also AC, first and last, with DF. All right, we'll look at that a little bit more, so hopefully you can get a better understanding. So this unit 4, is transformations. And the two that we're gonna focus on today will be reflections, which is like a mirror image. And it could be reflected over the y-axis, or it could be reflected over the x-axis. We'll look at both. A translation is a slide. It can go up, down, right, left, and the SL in that word helps you remember that it is a slide. Now, on both of these types of transformations, the item or object does not change its size or shape. It's just either reflected or moved. So same size and shape, just translated or reflected. So let's look at translations first. So this, you probably learned about translations, reflections, and stuff like that in 6th, 7th grade, but this part of it is new, where you have to write it algebraically. So with translations, when you're moving it, it's changing those x, y coordinates when it's on the coordinate plane. So if you move it to the right, the x coordinate, you add the number of units that it was moved. If it's moved to the left, it's subtracted. And then for up and down, the up is the y. So remember, up and down is going to be y. So y, that when you move up, it's added. You move it down, it gets subtracted. So remember, these have the same exact size and shape. It's just moved without rotating, resizing, or anything. It's just moving it. And that's what a translation is. All right, so every point of the shape must move the same distance in the same direction. You can see that point going, this one, and this one. So this one, please make sure you either take a screenshot and save it electronically or jot this down. You need this for your notes. This is not on the 8th grade STAR reference materials. So let's just practice a few problems. It says a polygon on a coordinate grid was transformed using this rule. This was the coordinates. And look, it's minus 4 units, minus 3. Okay, so remember, if it's minus on the x, it's moved to the left. If it's minus on the y, it goes down that number of units. So let's look at that again. X minus 4. So let's start with that part. So that means it's going to go 4 units to the left. So first one says a translation 4 units to the left. Okay, that one's good. This one's not. So we can eliminate a couple of answers there because 2 of them say to the right, and that would have to be a plus 4. So this one says to the right, and this one says to the right. The next part of it says y minus 3. So that, remember, is down. Here's this right here. Looks like A is the correct answer. If you look at C, what makes it wrong? It says up. Let's try another one. So it says the coordinate grid shows a pentagon. The pentagon is translated 1 unit to the left. So every point would go to the left 1 unit. So remember, left is minus, that's the x coordinate. So that's going to be like x minus 1. That's how it's going to be represented. And then the next part says it's 10 units down. And so up and down is the y. So y minus the 10. So all we're doing is looking for the rule that describes that. That always will start with, this is our original coordinates. What happens to them? You subtract 1, subtract 10. Oh, looks like A is the correct answer. This is wrong because it says plus 1 there. C is wrong. It says plus 10. So that would be up on the plus 10. And then D says plus 1 and plus 10. So those are both wrong. All right, let's go ahead and do, I think this is our last one for practice with translations, and we'll move on to reflections. So triangle RST is translated 6 units to the left and 4 units up to create the new triangle. So that's another thing I want to point out to you. So this one does not have these little, what we call prime. So that is the original one. So when you see it with not the little, no primes, this is the original one. This is the new one after they've done the translation. If it goes 6 units to the left, remember that's going to be our x. Left and right is x, so x minus 6. And then 4 up would be y plus the 4. So this is our original, and this shows multiplication, so that's definitely wrong. The next one also shows multiplication, wrong. All right, so this says plus 6, so that would be to the right, and it needs to go to the left, so this is wrong. This is to the left, minus 6, this is going up, that is correct. And just a reminder here, are the 2 triangles congruent? They are. We didn't change the size or shape. They're the same size, same shape, so they are congruent. All right, so next part we're going to do is reflections. We're going to look at the rules here. So when you have a reflection, so this is our original triangle here, and this is the new one. This one is reflected over the y-axis. So it's flipped over. So what happens with the rule here, when it's over the x-axis, the x I'm sorry, yeah, so when it's over the x-axis here, so this is that. Let's look at this one first. So sorry, I'm going to go down to here. So across the y-axis, like this example right here, your x's become the opposite. So look at that. So here's your original c, which is, let's just say it's at -1. Here's your new c, it's 1. So the x becomes the opposite, but all the y values are staying the same. That's exactly the same y value. And the a is the same y value. Now when you look at another, if we had another example with the x, then this is what would happen. Your x value stays the same and the y's become the opposite when it is rotated or reflected across the x-axis. All right, let's look at a couple of examples. And so I didn't point this out. So remember, they are still congruent. They're just flipped or reflected. All right, so here we go. So which best describes the transformation of quadrilateral JMYA to BSKN? So they use totally different numbers, but it's just reflected. So this is reflected to this point. This one becomes this. So it's just reflected, flipped over. So is it a reflection across the y-axis? Is it a reflection across the x-axis? Is it a rotation? Or rotation means it's going to be turned, so it's definitely not rotations. So we're going to get rid of the last two. And when you look at this, this is our y-axis, it is reflected across the y-axis. So the first one is the correct answer. The x-axis, then that would be down here. Something like this, and then you have 2 more points. So that's where that would end up. All right, last one, practice problem. We have a pentagon, and this was a star question. So we have this pentagon, VW XYZ is shown on the coordinate grid. A student reflected the pentagon across the x-axis. So this is our x-axis, so this one's going to get reflected up here. I'm just going to put a point there just so you kind of visualize this. So the V prime would be here. The Z prime would be here. The W would be here, and so on. So just so you have that visualization. So notice, look, if your X values aren't changing, if you look at that, the X's are the same. This is still at 4. This is still at 1. And this is still at 7. But what did change is now the Y values are the opposite. So this one is -1 and the new one is 1. So then we're looking for that rule, original, new, X stays the same, Y is the opposite. That is correct. Look at B. Yes, that is not correct. This one, they switched this around. That's not right. And then here, that would have been, it was reflected over the y-axis. So if you have questions about that, please reach out to me. Please make sure you complete the Ole Miss lessons for this section and do the practice problems. And again, if you have questions, just reach out to me.